pioneer is Dr. Richard Riman, a distinguished professor at Rutgers University. He is focused on the discovery and development of green manufacturing methods for the production of ceramics in order to provide sustainable solutions to significant technological and environmental problems. He envisions a world where all people can access and implement sustainable technology, which is going to be the topic of his talk tonight. Please join me in welcoming Dr. Riman.
Thank you very much. Just waiting for my slides to get queued up. So one of the things I want to emphasize is I'm going to present technology to you that can engage all walks of life, whether you've graduated high school, college, gone to graduate school, or never went to school at all. There's a place for everyone in this technology, and that can create jobs. So going to the second slide, what I got is a toolbox. And this toolbox is going to empower communities and businesses to create infrastructure in the form of materials, energy, sanitation, as well as reclaiming land. So when I talk about energy, we heard how important having electricity would be. This is going to provide electricity. So what's the problem? The problem is that countries that are out there now that are modernizing are using outdated, unsustainable technology. China is a great example. 50% of the concrete made in the world is made in China using really outdated technologies where coal is firing the materials. And if you've been to China, you know that you probably have to take a shower about twice a day to get all the soot off your body. And if all the countries out there feel entitlement to their turn to pollute the atmosphere, we've got a big disaster coming. So what we really need is sustainable, portable, scalable technology that can be used by communities and companies. So whether we make money at it or everybody pitches in to get it done, this technology is going to do it. And we have two materials that are going to drive this. One is going to be concrete and the other is going to be trash. And trash is going to have a totally different meaning if this vision can be carried out. Let me explain why. First of all, concrete is not cement. Concrete is a mixture of cement, sand, and gravel. It's made at high temperature, and there's a huge amount of energy that is consumed as a result of it because it's the second most consumed material in the world next to water. This technology is responsible for producing up to 10% of the global CO2. And we all know that greenhouse gas, global warming is an issue. Regardless of whether you believe in climate change or not, there's no merit to making more CO2. And then from the trash side, us Americans are gluttonous. We create about 3/4 of a metric ton per year per person of garbage. And only 1/3 of the total garbage produced in the U.S. alone is recycled. The rest of it goes where? Into the landfill. So what if every country in the world had a turn at doing that? We have a tragedy in the making, such as modernization. So the opportunity is to put together two proven technologies. First of all, one of the technologies is an invention created by my research group at Rutgers, and I call it carbonate cement concrete, or C-cubed. And what C-cubed can do is we can take minerals straight out of the ground and turn them into a cement. Okay, and I forgot to bring them up on stage. I'll bring them up later, but I've got samples to show you. I've got rocks I've taken from New York State, and I've turned that into a cement without ever heating it. All I have to do is dig it out of the backyard, crush it up, and expose it to CO2. Okay, so that's another cool thing. This stuff loves to eat CO2. We no longer need water to harden the cement using this technology. The other technology that's out there, if you're not lucky enough to have the minerals that you need, we have thought of just about every type of mineral combination that you can think of so you can do it locally. You can dig stuff out of your backyard, and if you can get a little limestone, which is everywhere because at one point the whole world was underwater, and that's where all the limestone came from, all this dead shellfish. We mix it with these materials, and we can make cement. And I started a company that's now globally commercializing this technology. And as we speak right now, we're able to literally keep millions of pounds of CO2 out of the air just out of one cement plant alone. Okay, so, and the energy savings is huge. It's at least 30% less and at least 70% less CO2. The gasification technology, I gotta move fast, it was invented by the Army. It's been deployed already in Afghanistan, and it takes trash and it turns it into CO2, water, a small amount of ash that can go into your concrete, and guess what? Electricity. There's nothing left to throw out. Zero footprint. That means better land, and also if you don't have garbage all over the streets, you have better sanitation. So I'm going to skip through most of this except to tell you that this concrete, it was so good that I never bothered to ask the U.S. government to fund me to do it. I went to the Silicon Valley and I got funded to do it. That's how I founded this company, Solidia Technologies. This material can last at least twice as long as any concrete that's ever been made before. We could save $2 billion a year in maintenance of roads and bridges in this country. Now, that's another thing you want to get me on, but we're not fixing our bridges right now, even though the Department of Transportation knows this technology exists, because they don't have any money from Congress. So we need everybody to start writing them letters and saying, what the hell are you doing there? Okay, now, this slide shows you how easily it can be done. You can make this stuff in your kitchen, okay? So that empowers people, because imagine you can make 10 tiles a day as a single person, and you've got 100 people. That means that you can make an awful lot of tiles per day, okay? And this machine that I was telling you about that makes electricity, it can generate, and it's been proven to generate enough electricity on a ton of garbage a day to basically power a base of 600 soldiers, okay? So, and we've scaled up the process. Solidia Technologies, again, commercializing the technology, has made full-scale pieces of concrete. We've also had production processes run at 2,000 tons a day with 30% energy reduction and 70% reduction in CO2. And also, this technology, I had another military technology that I'm familiar with. It can take CO2 and water and create potable water that you can drink or use for casting your materials. And casting is the easiest way to do it. So you take all this stuff from the kitchen that I just showed you and throw it into a big shipping crate, and now you can ship it all over the world, and you can drop ship it by helicopter, and you can teach people how to do this technology. So the equipment that's shown on this slide here, I don't know, this pointer doesn't work. Anyway, you've got, a machine that's going to grind the mineral into small pieces. You got a mixer that can do a ton every 90 seconds. You've got this roller thing here for making water pipes that can deliver fresh water if you want. You can cast concrete with fabric as well. You don't need to have wood or metal as casting forms. When you solidify this stuff, you can use a glad bag if you want, or you can use something fancy like this trailer shown. And then you've got the electricity generator from garbage, which the Army has. And again, it could fit on this stage, 3/4 of the size of the stage. So in the end, what kind of impact would this be if we could get everybody to jump into this? We could avoid the release of enough CO2 to cover all the mass on the Earth in 3 feet of pure CO2. Or we could have something that equals the mass of 10 Empire State Buildings. We can generate enough electricity to power half of the USA and 2 free tanks of gas for everybody in the world, and enough water to fill Lake Erie twice,
Have to be fair.
and more land. Okay.
That was lovely.
Going to be opening it up. Microphone working?
Yeah.
I don't think I was saying that at volume.
I didn't hear you.
You didn't hear me? You're deaf. I think the people back there heard me, right?
Right. So just in understanding one thing, you mentioned the durability, it lasts for a longer period of time. What about the strength of the product that comes out?
Oh, the strength is awesome. It's 5 times the strength of high-performance cement. We can generate a 200 megapascal compressive strength. An undergraduate can do it. Ordinary cement is on the order of about 30 megapascal, high performance of 50 megapascal, and we do 200.
Right. So now in distribution, just the secondary question of the useful life of the product, how long does the machine last? Is it subject to significant maintenance? It's
That's where a lot of the work has to go in. We have to see how reliable these machines can be, how much automation can we actually input, given that you're in the middle of nowhere.
Right.
Okay, and remember, everything has to be powered by garbage. We're not going to have, an Exxon station down the street.
Thank you.
I just had a question around, has there been any thought around the health implications of this? What I mean is, the garbage being used. Are people going to go around looking for garbage because now garbage is the next commodity, as like gold and silver?
I would love to have that happen.
People are planning to use it at home in their backyard, or those kind of things.
I think people will make those decisions for themselves. But to build one of these machines, which the Army calls Tiger for TGER, Tactical Gas to Energy Refinery, that's going to cost a bit of money. But it's going to be a lot cheaper than shipping things out to people who don't know how to be self-sufficient. And also, by the way, I've got ideas for agriculture and a whole bunch of other things to make things work that can actually run off of this technology. I just don't have the time to get into it right now.
You only have 8 minutes. Right?
That's right. And I had a hard enough time getting it in with this, and that was just the concrete part.
So my question is, one of my favorite TED Talks of all time is Simon Sinek's Law of Diffusion of Innovation. So this sounds like the greatest thing since sliced white bread. Why aren't more people using it? Where are you on that innovation curve? Is it just mostly being used by the innovators or early adapters? How far do you need to go before we hit that spectrum over?
Okay, so no offense to anybody that's in politics or in financing, but most of those people are lemmings. They want to see everybody else going first before they go. I can tell you because I just raised money for my startup company, and I had to literally beg for that. They wouldn't even allow me to raise the value of my company on the second financing, and we met all of our goals. So, I love hearing that, money is going to follow the crowd, but I haven't seen it yet. And that is a real shame because we're getting stuff done. I'm not doing IT stuff, and that's what they don't like. They want 1,000-fold increase. I only did 6-fold, But the number of jobs that I could create will blow away any IT. Because there's over 40,000 people that work in the concrete field in the United States alone. And right now, the Canadian government's giving me money before the United States money has. And they're going to spending $1.7 billion in the United States to create the Future Gen plant that's going to put 100,000 tons of CO2 under the ground. In Canada, we're going to do it in 6 years for $13 million. And I can't get the DOE to listen to me. I've gone to the President's Office of Science and Technology Policy. They love what I have to say, and they say, go ahead and build, excitement for us, and when you've got, an army of people behind you, come back. Oh, you know what? I'm trying to solve the problem. I'm not trying to be Mr. Popular here. So I would like to understand this crowdsource idea and how to do that, but if I spend all my time learning how to do that, then I can't get this problem solved.
Thank you. Appreciate it.
Yeah, I could use some help, is what I'm saying.
Thank you very much.